The quantum theory behind smell. If you are a curious mind, you have probably wondered why compounds which seem so similar in shape and functional group have very distinct smells. Take for example vanillin, which has identical functional groups to its isomer isovanillin, yet vanillin is what causes the smell commonly associated with vanilla, yet isovanillin has a sickly sweet smell. So how do we differentiate between these two molecules? One of the early theories, called shape theory, attempted to explain this as a result of the odorous molecule binding to olfactory receptors, which then adjusted to better fit the molecule. This is called the docking mechanism. This seemed to explain much of smell, yet many similarly shaped molecules smelled very different, such as limonene and dipentene, which, as you can see, differ only in the orientations of their lower chemical groups, so it is that were limonene's chemical group to be flipped so that the bond was pointing upwards, the double bond would also change sides from left to right. Another theory at the time was vibration theory. It stated that your olfactory receptor used a kind of spectroscopy called Raman scattering, wherein a source of light was used to fire photons at a molecule, and the re-emitted photons were measured and recorded as the re-emitted light depended on the vibration and energy of the electrons in the molecule's bonds, which themselves depended on the surrounding chemical environment, producing a unique spectra for each molecule. This vibration theory would have explained many things about smell. It was mostly ignored, however, due to the glaring issue that noses do not glow, so there would not be any photons to measure. Some scientists continue to believe in vibration theory, however. These scientists eventually created the most successful theory of smell in history. But to understand that, we need to understand inelastic electron tunneling spectroscopy. Inelastic electron tunneling spectroscopy, or IETS, is a very complicated mechanism, so I shall explain the fundamentals first. An electron is a particle, but as it has energy, it can also act as a wave. While acting as a wave, the particle can effectively be anywhere in the area of its wave. This can allow electrons to cross energy barriers that are seemingly impossible to cross, as there is a non-zero chance that the electron can be across this barrier. If crossing this barrier moves the electron to a lower energy zone, it loses energy. This is called inelastic electron tunneling. In olfactory receptors, we can think of this as two plates, between which the odorous molecule sits. As electrons jump from donors on one side to acceptors on the other through the molecule, via quantum tunneling, it loses some of this energy. The olfactory receptor knows the energy of the electrons on the donor side and the energy of the electrons on the acceptor side, so it knows what the bond looks like based off these facts. With this information, along with the information of the shape of the molecule, any possible molecule can be identified. When such a molecule is identified, your brain is notified and produces the sensation of a smell. Thank you one and all for watching, and until next time.